when simplifying expressions with exponents like these ones is, how do we know, and this is a question you're going to have to answer for yourself every time you work one of these problems, how do we know when to add exponents and when to multiply exponents and when to subtract exponents and when to divide exponents? How are we going to know when to do each of those things? So we'll come up with a little table here. So do this to exponents when what? So in the example that we just solved, we saw one case in which exponents were being added. We saw another case when exponents were being multiplied. So just for the sake of getting our solution down on the screen, so it goes into our videos as well, when we solved this problem, the first thing that I recommended doing was changing this negative sign to a -1 coefficient, so that when the quantity inside the parentheses got squared, that square applied to all the three factors inside the parentheses and gave me -1 squared, followed by x to the third squared, followed by z to the fourth squared. And then we still had the rest of these factors, 2x squared, y to the third, z, out in the front here. And now at our very next step, what happened with the 3 and the 2 that were the exponents next to the x here? What did Allison do? Multiplied. So there was an instance where we multiplied exponents. And so the question I have, and Allison mentioned this a little bit, why do we multiply here? How do we know that multiplication is the right thing at that stage? What is it about the expression that tells me that I should be multiplying? The exponents are outside of these parentheses, these ones right here, right, and this one right here. And so what are we doing? And so being outside the parentheses is kind of a tip-off. Exponent outside parentheses. Because what's really happening there is that we're raising a power to a power. So power of a power. When you raise a power to a power, the exponents multiply, which is why we end up with x to the 6th and z to the 8th at that stage. I have 2x squared, y to the third, z. But then from that line to the next line, what did Allison do here? X to the 6th and x squared combined to give us x to the 8th, because what were you doing? Adding. So there's an instance where we chose to add instead. And so then my question again is, why did we choose to add in this example? How are we going to know in future problems when to add exponents? So when they're not, all right, so when the exponent is not being applied to a power inside of parentheses, but instead the exponents are just kind of sitting, the two different powers are just sitting on the same line here next to one another. What would we say is happening to the quantity x to the 6th and x squared? If I put some parentheses in there, like I just did, right, does that change our thinking at all? No, why not? Why is that the same thing as what we had before? So the powers are still inside the parentheses. And what are we really doing with x to the 6th and x squared? X to the 6th and x squared are being multiplied by one another. So we're multiplying two powers, such as x to the 6th times x squared. So the difference is a difference in the type of arithmetic that we're doing to the powers of x or y or z. Right? That exponents add when the powers are being multiplied, x to the 6th times x squared. Exponents multiply when the powers are being raised to powers. And anytime we raise a power to a power, you'll always see parentheses around the inside power. Right? That was the visual element that you were noticing that led you to remember to multiply here. But the arithmetic behind that is it's because we're raising a power to a power that we would multiply exponents. So keeping addition straight from multiplication in working with exponents is probably job number one. That if you get that, down, if you groove that, then that gets you a long way in problems of this type. So then the only operation to exponents that we haven't talked about is when would we subtract? We didn't have to in problem number 1. But what do you think? What's your hunch? If we add exponents whenever we multiply powers, when do we subtract exponents?
Divide.
Yeah, exactly. So anytime we divide 2 powers, we would subtract their exponents. Such as, for example, x to the 6th over x squared. There we would subtract the 2 exponents, which we didn't have to do in problem 1, but we probably had to do in problem 2.